Gernot Wagner is a climate economist and currently the Associate Professor of Environmental Studies and Public Service at NYU. Prior to that, he was the founding executive director of Harvard's Solar Geoengineering Research Program and served as lead senior economist at the Environmental Defense Fund. And he is the author of the fascinating new book, Geoengineering: The Gamble. Gernot Wagner, welcome to the Climate Pod.
Thanks, Ty.
Well, it's safe to say that geoengineering is kind of a controversial topic, especially in the climate world. So what made you want to write this book?
To stir up a little bit of conversation? No. Yes, of course, right? Geoengineering writ large, maybe especially solar geoengineering, is highly controversial for good reason, right? So this is not one of these, oh, I wished we would all just get along and we wouldn't have to have these conversations. No, it's controversial for good reason. And we should be having the conversation. And frankly, that's the point, right? The point is not to pull the trigger or, dear conspiracy theorists, stand down, keep your letters to yourself. No, nobody's doing this right now. Nor should we. The point is to have the conversation. The point is to figure out whether and how we should be studying the topic and considering it to be a potential part of the much, much broader climate policy portfolio.
So you're a trained economist. As an economist, why did you want to study geoengineering in the first place?
So geoengineering, solar geoengineering, right? So let's get the definition straight, right? So
okay.
Carbon removal, often usurped in this broader topic. And by the way, I do that too, right? So the book title is Geoengineering: The Gamble. Now I try to clear that up right from the beginning, essentially say, look, yes, some people, lots of people, subsume both terms under one heading. And there are some reasons to do that. But for the most part, they are just two very, very distinct things happening here. One is carbon removal, literally sucking CO2 back out of thin air. We should be doing that too. We should look into that. Now, frankly, the properties here, the economic properties, it's basically just currently very expensive mitigation, right? So yeah, we need to cut CO2. That's, priorities 1 through 5. Let's get on with it, right? We should have done much, much more of that a long time ago. Yes, we need to adapt to what's in store. And that's priorities, either the first one, depending on your perspective, or it should be, priorities 6 through 10, right? Is about adaptation, resiliency. And then there is carbon removal, which is, frankly, expensive mitigation. It has its own, there are some properties that make it worthwhile calling out on its own. But at the end of the day, we are not going to get to sucking CO2 out of thin air at scale unless we have basically priced CO2 to such an extent that we have basically mitigated, cut CO2 emissions in a big way. Okay, so, right, that's number 3. And finally, right, here's the real topic, the solar geoengineering, which is, in fact, very controversial for good reason. And it's also pretty interesting. It has the exact opposite properties in many ways from cutting CO2 emissions. The name of the game here is not how do you motivate people to do more of it, but frankly, how do you stop them from doing too much, too soon, stupidly?
And we are going to definitely get into that. And I want to make sure, though, like you said, that the audience knows exactly what we're talking about. You're able to define there the difference between geoengineering and solar geoengineering, which is what we're talking about, and carbon capture. But as far as solar geoengineering, something like this has actually happened in our lifetime. In 1991, a volcano erupted in the Philippines and the global temperature decreased by 0.5 degree. So what did researchers learn about how the planet was affected by that eruption and the sudden drop in global temperatures?
So quite a lot. And yes, right. So when you say this has happened, right? So in many ways, it obviously, we did not deliberately explode a volcano, right? And not to put too much of a final point on this, but actually that matters a lot, right? There is a big difference between deliberately pulling the trigger, right? Choosing to do so versus, shit happens, right? So in this case, volcano erupted, right? But Mount Pinatubo in the Philippines in 1991. And yes, in 1992, by the way, right around the time of the Rio Earth Summit, right around the time, right, the 160 plus heads of state come together for sort of the very first big, environmental sustainability shindig. And at that time, that month, sort of June, July, 1992, global average temperatures were about 0.5 degree centigrade, almost 1 degree Fahrenheit, cooler than they would have been were it not for the volcanic eruption. And by the way, up to that point, we're talking about 1992, right? Early 90s, global average temperatures had risen because of climate change, unmitigated climate change, by about 0.5 degree centigrade, almost 1 degree Fahrenheit. So, you can say that year, the volcano wiped out temporarily, and that's a key feature here too, all global average warming up to that point. Now, you need to add a few other things immediately to this. So one, a few hundred Filipinos died because of this volcanic eruption. Now, turns out there was not just a volcanic eruption. Around the time, there was also a cyclone, major storm hitting the Philippines, right? So you were caught between an exploding volcano and a storm surge, right? And lots of other confounding factors here. That said, right? So first of all, was the volcanic eruption a good thing overall? No, people died. Did it decrease global average temperatures? Yeah, it actually did. And yes, right, scientists, climate scientists, right? So not me, economist. Climate scientists have been studying the effects on lots of things, right? Global average temperatures, ozone loss, lots and lots of other things. Crop productivity, for example, right? In the months and years following the volcanic eruption, did the lowering of global average temperatures do something to plant growth, to crop productivity? And all these topics, of course, are worthwhile studying. And frankly, as far as research funding, research emphasis go, should we get ready for the next volcanic eruption to, have our satellites trained on it and sort of be able to study in a volcanic eruption much, much more than we were able to do sort of ex post after the fact? Yeah, we should be doing that too. Now, that's not everything, right? There are other aspects of solar geoengineering research, but yes, there's certainly a lot to learn from a volcanic eruption like that.
So if humans were to try to replicate this effect based on your research,
we would not be exploding volcanoes, just to be clear. But,
so what is it? What are the most effective methodologies?
And here is where it gets interesting. So, and when I say it, right, when we talk about it, so we are no longer just talking about solar geoengineering writ large. Now we are talking specifically about stratospheric aerosols. Aerosols, tiny reflective particles. If you have them in the lower stratosphere, they reflect sunlight, solar radiation back into space and cool what is underneath. That's the general phenomenon. And frankly, not to be too simplistic, and of course, plenty of people would accuse me of being too simplistic here, but this is sort of the same phenomenon why we wore white between Memorial and Labor Day, and why winter jackets are black, right? So white reflects and cools what is underneath. Black does not reflect and warms, relatively speaking, what is underneath. This is like your middle school science experiment, right? You put an ice cube on a white surface, you put it on a black surface, which one melts faster, right? That's called albedo effect, right? And yes, white is more reflective, which, right, sort of in the broader climate world, there are sort of analogies here or interesting manifestations of this phenomenon here, right? So white ice sheets, floating sea ice, turns out to reflect sunlight back and makes the surface cooler relative to relatively dark open waters, right? So you have this feedback effect, positive feedback, what scientists call positive feedback, what the rest of us call very, very negative outcome of ever more heating resulting from the melting, resulting from a change in the albedo. So yes, that's technique we are talking about, right? Stratospheric aerosols. How to do it? Well, no, not through volcanoes, right? These things throw up a whole bunch of other gunk, lots of other effects. So the way to do it ultimately is through planes, through high-flying planes. And again, right, dear conspiracy theorists, no contrail up there is currently spewing chemicals, so take off your tinfoil hats. Not happening as we speak. And actually, that's an important thing to talk about for different reasons, because no, current planes aren't in fact capable of doing that. You need planes that fly quite a bit higher into the lower stratosphere. Yes, we have those planes too, right? The U-2 spy plane, the ER-2, the civilian version can fly that high. Certain military planes can fly that high. But frankly, right, the U-2 is it's a pilot in a spacesuit plus a GoPro, right? So not quite the equipment that they have up there, but it's not, there's no payload involved, right? So no, the U-2 spy plane is not the one used for any of this either. You need a plane with massive wingspan and a large fuselage, right? Large capacity, relatively large capacity. And no, these planes don't currently exist. But, and yes, this is where it gets interesting. When you actually go out, and a co-author of mine, Wake Smith, he actually did the hard work of calling up aerospace engineering companies and basically saying, hey, no, we're not trying to do this right now, but what if we were to want to? Would you, Boeing, Airbus, Bombardier, be able to design a plane like this? And frankly, every aerospace engineer you talk to says, well, this is interesting. Like, nobody's ever asked. This is not what we usually do, right? We don't get massive payloads up and have the plane fly down immediately. Not sort of what's usually, we don't think about that usually. But now that I'm thinking about it, yeah, that's doable, right? Massive wingspan, large fuselage, powerful engines. It's a new thing for us. We don't think about it in these terms, but could we design a plane like this? Yes. And now the economics, well, we're talking about designing a plane, right? So this is billions of dollars here, right? I'd have to sell a couple more books to be able to afford this one. Not that I would want to. So cheap is relative, just to be clear. But yeah, we're talking about single-digit billions of dollars, or let's call it $10 billion a year to be quote unquote doing this. That is very cheap relative to, right, the cost of cutting CO2 emissions in many ways. Now, to be clear, right, the cost of unmitigated climate change is the highest, right? So yes, let's get on with cutting emissions, of course, but cutting emissions still isn't free. Yes, right, electricity, solar PV, cheapest form of electricity in history, right? IEA is right in that statement. And yes, we should be deploying many more solar panels, solar power plants, and so on and so forth. Cutting CO2 is priority one. Yes. But when you look at the properties of solar geoengineering, it's cheap. If anything, it might be too cheap. That's, of course, now what makes it rather interesting from, right, a science perspective, and climate economic perspective. And yes, that's what makes it interesting to think about the implications of it being so darn cheap.
Yeah, I mean, you talk about the fact that it's so cheap leads to the free driver effect. Can you explain what the free driver effect means and why it's so important to understand when you think about the likelihood of deploying solar geoengineering?
So that's you might call it a QT way, right, of talking about, frankly, what most of us know under the free rider effect, right, which is basically sort of the purest economic take on these things. There are some good political economy reasons why the free rider effect itself might have been overplayed in sort of the broader climate conversation. But what is the free rider effect? It's in nobody's self-interest. Not that we could be doing it, even if we wanted to, but it's in nobody's self-interest to be going first or doing more than, in some sense, is necessary for our own benefit. And of course, you and I, different story, right? We might be cutting emissions ourselves because it's the moral thing to do, right? Now, of course, right, there's 7.8 billion of us. Not everyone has the same morals, and so on and so forth, right? Lots of stories there to tell. More importantly, of course, now we are talking large companies, we are talking countries, and so on and so forth, right? And no, it's in nobody's sort of individual's interest, that if the individual is literally an individual, a company, a country, to go first, do more than is necessary, so on. So you have this free ride effect, right? We are all riding off each other. And none of us is solving the problem. Free driver effect is, the opposite, where it's not that the social benefit is so diffuse, and the cost, the personal cost, simply isn't worth it because the benefit to me doesn't justify me incurring the extra cost. For the free driver effect, in the extreme, you basically assume that acting costs nothing, zero, which you might as well assume, given that we are talking about single-digit billions of dollars relative to trillions of dollars of potential benefits, and so on and so forth, right? So in the extreme, you have zero cost, while with literally zero cost, you don't have to assume much in terms of potential benefits to you as the person pulling the trigger here, that if anything, now we need to stop you from doing it, right? Free driver, like you might be driving too much because it's free for you to do so.
Yeah, I worry by simply comparing the cost of geoengineering versus the cost of decarbonizing, we're always going to come up with, the answer, which will be, let's turn down the sun. But we know that decarbonizing has tons of other benefits, better air and water quality, tons of new jobs, all kinds of great benefits. The list goes on and on. How do the benefits of solar geoengineering stack up against the benefits of transitioning to clean energy?
Okay, so just to be clear, you saw me violently nodding my head while you described the co-benefits of, right? So yes, of course, right? So again, let's not kid ourselves, right? We have to cut CO2 emissions, full stop. And yes, there are vast additional benefits of doing so, right? We stop causing local air pollution. We stop knocking off IQ points in our kids due to those other effects. So if we cut CO2 emissions by, let's say, moving to cities, right? So, if you live in New York as a New Yorker, you emit half as much CO2, a third of the CO2, as if you were to live in the burbs, right? And of course, it doesn't go just for New York, right? It might be sort of the extreme case because, the burbs are extreme cases of, suburbia around here, right? While New York City itself is sort of a somewhat extreme case in terms of urban mobility and urban living, at least here in the US, right? But if you sort of go for sort of an extreme case like this, yes, there are great additional benefits. And yes, right, just to be clear, right, let's ban cars from cities and sort of go all out. Of course, full stop, right? We have to do all these things, and there are fantastic benefits in doing so. Cool. Okay. Here is a cost of cutting CO2 emissions. And that's actually sort of this thought experiment led to what you might call this current resurgence in interest in solar geoengineering research. So it was the late Paul Crutzen, Nobel laureate, right? He won the prize for science leading up to the discovery of the ozone hole, and us getting on with fixing it, Montreal Protocol. So all good things, right? All important things. Okay, so a dozen years or so ago, he wrote this very speculative essay that basically talked about the need to cut emissions. But if we were to cut emissions overnight, let's say, not that we could do that, but if we were to do that, global average temperatures might actually increase fairly rapidly, fairly dramatically. Why? Because of all the other gunk that we emit when we emit CO2. So when we emit CO2, we also emit SO2. SO2, tiny reflective particles. Now, in this case, it's in the troposphere where we live, where in fact it kills 6 to 8 million people or so per year, which, yes, let's stop doing that, of course, right? One of the nasty, nasty side effects of our fossil age is that we cause so much local regional air pollution that we kill millions of people a year due to that local air pollution, right? Now, let's stop that. Okay, if we were to, and actually by now we can look back at cases of countries, continents that have done so. So Europe cleaned up its act relatively early in terms of SO2 pollution. As a result, the Arctic is currently approximately 0.5 degrees centigrade warmer than it would have been had Europe not cleaned up its act. Why? Because SO2 doesn't just kill lots of people, doesn't just call acid rain and have medieval cathedral melt in the rain, literally, right? It also cools what is underneath, the reflective particles cool what is underneath. So that's a trade-off, right? I'm loath to call it a benefit of pollution, but just to be clear, yes, it is. There is a trade-off here. There's a real trade-off here. Now, again, don't throw stuff at me now if I say it's a benefit of pollution, but yeah, right? There are trade-offs. And Paul Crutzen wrote this speculative essay basically saying, okay, in some sense, similarly worded, right? Don't throw stuff at me immediately, please, right? Here, let me hold up my Nobel Prize as a shield here to defend myself from all the stuff coming at me. But what if one were to think about deploying solar geoengineering in order to avoid this hard trade-off here, right? Yes, let's agree to cut pollution, CO2 pollution, SO2, local air pollution. Now, at the same time, let's also agree that having global average temperatures increase rapidly overnight, more or less, within weeks, would be bad. So in order to avoid that from happening, let's introduce small reflective particles, sulfate aerosols, that we are no longer putting into the troposphere, the lower atmosphere, into the lower stratosphere, 20 kilometers and up, where nobody lives, right? We're not killing anyone directly. Yes, there are health effects, negative ones. We should talk about them. That's important. But it's sort of an order of magnitude, or 50 times less up there than down here. So, in a, to be clear, 1-2 rational world, right? Nobody could ever dream of actually implementing such a trade. But in this rational, 1-2 rational thought experiment, yeah, maybe it makes sense to do both at the same time. Cut pollution down here while deliberately introducing order of magnitude less pollution up there, solar geoengineering, stratospheric aerosols, trying to address this trade-off of rapidly increasing global average temperatures if we were to cut pollution down here.
Well, you do such an incredible job in the book of laying out so many of the objections to solar geoengineering. Some of them that I've heard of, and honestly, there are some I hadn't. And I think you've got a pretty honest assessment of every one of those objections. For example, you explain that the stratospheric aerosols won't lessen ocean acidification. This is going to continue to get worse as we burn fossil fuels. And spewing those sulfates in the air, we're going to further deplete the stratospheric ozone. So, will the planet actually be sustainable for human life if the oceans are too acidic to fish and you can't go outside for risk of getting skin cancer due to the depleted ozone?
So are you saying that would the planet be sustainable to live if all we did were solar geoengineering and nothing else? And the short answer is no, we should not even be thinking in that direction. Of course not, right? Again, this is not an either or. It must not be an either or. And yes, I'm sure we'll get into the moral hazard of it all, right? Solar geoengineering versus cutting CO2 emissions. That's an important topic. And no, it must not be an either or. Now, all that said, and immediately responding to especially the second bit you mentioned, right? So no contest on ocean acidification, just to be clear, right? We have to stop putting CO2 into the atmosphere in order to combat ocean acidification. And actually, this is sort of, there's a bit of a confession in there myself. So I wrote a paper once that in some sense as an add-on at the end, that was not the point of the paper at all. It was basically about the carbon benefit of solar geoengineering, right? Let's hypothetically quantify what carbon benefit there is, in the sense that if you, again, thought experiment, let's not ever do that. But if you were to not do anything about emissions reductions, only did solar geoengineering, what's the effect on CO2? And turns out it's a positive one, because you're basically turning off the feedbacks. You're turning off the geophysical feedback mechanisms here, because you keep temperatures constant. Again, hypothetically. And in some sense, as an add-on there, we basically then said, oh, hold on a second, ocean acidification should have, right? It should also have a positive effect on ocean acidification. Turns out we were wrong. Others, Kate Rickey, most prominently on Twitter, actually at the time, I remember that she, picked up my paper somehow and tweeted basically, a very nice, not the usual Twitter response, a very nice response, basically saying, yeah, no, sorry guys, you're wrong here, right? And yes, no, I think I understand now why. I'm sure she does much better than I do, but the short version is it does not address ocean acidification. On the ozone front, there's actually a big difference here between arguing that if we were to do solar geoengineering, we would, right, reopening the ozone hole, everything we accomplished through the Montreal Protocol is out the window and, all hell breaks loose. That's a slightly different take than saying we would delay stratospheric ozone recovery, right? So instead of projecting that we will have fixed the ozone hole by a certain date, it'll take us a decade longer, right? There's a big difference here, right? Now, to be clear, still not good, right? That's a trade-off here. It is, but it's not like sort of the trade-off of, right, everything we know about stratospheric ozone tells us that if anyone ever were to contemplate doing solar geoengineering or deployed it, right, we would simply reopen the ozone hole, and we are back in the late 80s with nobody having done anything about ozone, stratospheric ozone, right? No, not quite, right? We delay the recovery. And again, there too, right? So there's some fantastic climate science, the modeling studies out there. Simona Tilmes happens to be the climate scientist who has led that work, much of that work. And it's important to get right. That said, yes, there are trade-offs here. There are potential trade-offs with stratospheric, aerosols, sulfate aerosols. Turns out there is possibly a potential to do solar geoengineering instead of with an acid, with a base, possibly literally limestone, calcite, in which case, the very first study on that said solar geoengineering without ozone loss. Turns out it's not quite as simple. Further lab study basically complicated that particular conclusion quite a bit. That said, again, lots more research to be done here. It's not as obvious as saying, hey, solar geoengineering is going to kill stratospheric ozone. Not at all.
But even if we use whether it's calcites, sulfates, either one to kind of block the sun, won't that hurt photovoltaic solar panel efficiency, making it harder for us to use solar as an energy source?
If we were to actually block the sun, yes, obviously, right? So that sounds like some Simpson episode or some James Bond movie or whatever, right? So like. And in that one, no, let's not, right? Let's not go there, right? So what we are talking about, what anyone talking about solar geoengineering is talking about, at least sort of the genuine attempts of trying to get things right here is, right, a fraction of a percent of solar radiation, right? Which would make quite a bit difference here in terms of global average temperatures. Now, would that also have impact on solar energy? Yes, it would. But actually, there's sort of some, now we are in the minutiae here. There's a difference here between solar photovoltaic and concentrated solar. So it turns out one effect of stratospheric aerosols is more diffuse light. Okay, what does that do? What does that mean? It means for concentrated solar power, where you need direct sunlight, right, hitting the mirrors, right, and you basically channel all the sunlight, and actually all these look like sort of these, looks like something the Simpsons would have them somewhere in their village, right, in the city, Springfield, not a village, a city, where yes, you would expect a decrease in output for concentrated solar power. For photovoltaic, well, either not as much at all, right? Because we are talking about not direct sunlight, but frankly, solar panels these days also work in diffuse light and maybe actually work better in diffuse light. Now, all that said, yes, right? Best guess, first guess, sort of, if you turn down the sun, which is in loose ways what we are talking about here, by a fraction of a percent, yeah, you decrease solar output by a fraction of a percent. Is that a real trade-off? Well, it's a trade-off. Is it real? Is it basically and this is one of the reasons why solar geoengineering is the worst idea ever, and therefore we shouldn't touch it, because solar PV is going to decrease in terms of its efficacy, its efficiency is going to decrease. Well, no, because we're talking about a fraction of a percent, right? Now, is it good? No, but okay, so solar PV costs have come down, what, by a factor of 100 in 40 years, by a factor of 10 in 10 years, right? All good, all fantastic. Should we be taking steps backward here deliberately? No, but let's call it a percent, right? A percent decrease in solar output. Is that going to kill the global solar industry? No, of course not. Is it measurable? Does it matter? Yes, probably. But that's not the one reason that's going to kill solar geoengineering once and for all.
I'd say one of my biggest concerns, and definitely a concern that you address in the book, is the variability that solar geoengineering may have across different regions, the varying effects. So is that a valid concern?
Maybe. So there are, let me put it this way, there are lots and lots of good reasons to say, look, solar geoengineering writ large is a bad idea because we will simply abuse the technology. We never do anything rationally. I mean, newsflash, right? Like, look around, right? So have we addressed any social problem of late in the most rational possible way? No, right? We are currently talking on a climate podcast because we haven't solved this thing, even though had we done what we should have, we wouldn't be here right now, right? Like, we would be worrying about different problems and we would tackle those rationally and look, full on vaccine campaign later, right? Concluded within weeks as opposed to years. We have solved, right, yet another global problem. And of course, right, we are not currently as we speak. Okay, what's the biggest problem here? The biggest problem is that whatever we talk about should happen rationally, just typically doesn't, right? So the engineering, the technology, the science cannot ever be viewed in isolation as, hey, it would be good if, because there are behavioral quirks, behavioral reasons. There are, people with emotions and feelings and other priorities and political biases and Facebook news feeds, right? To scroll through and get the information from, who then therefore don't quite do what we ask them to. So frankly, and of course I'm biased here, right? Social scientist here talking about solar geoengineering. I don't think the most important solar geoengineering research questions are of a scientific, engineering, technological nature. Plenty of questions there to be answered, there to be asked and answered too. But the most important one, the most consequential ones, are along the lines of why are, 40% of Americans currently unvaccinated, right? Whatever the percentage is, and much, much higher, of course, in certain populations, right? None of that has anything to do with the vaccine technology. It has a lot to do with Facebook news feeds. It has a lot to do with many, many other factors where, frankly, the technologists, the engineers, the scientists just, better get out and leave the room, because that's not for them to try to answer.
Yeah, and you do such a good job in the book of moving the conversation from the science to the politics, and that is, you've already made reference to it. That's the real concern here. Let's take the United States for example. Pretty much the entire history of this country tells us that the U.S. is going to be happy to engage in something that helps Americans, even if it comes at the expense of other countries or even other continents. So are there any global treaties in place or anything that would outlaw or regulate such solar geoengineering?
Depends on who you ask, I think is the short answer. Clearly there, actually, let me put it this way. There are some activists on both ends of the spectrum, but frankly, in this case, more on the wanting to squash, wanting to ban things, who will point to certain treaties and say, oh, this is actually outlawing solar geoengineering activities, right? So therefore you are violating some law here by even, engaging in the research. Turns out not quite. Turns out no. Of course, all of this is up to interpretation, right? In some sense, the legal profession, unlike the hard sciences, and of course economics is this funny in between here and funny halfway house here between those two, right? In the legal profession, for very good reason, right, you can basically hire a very good lawyer who will make a compelling case for why you're right, and then the opposing side hires a very good lawyer who will try very, very hard to make a compelling case for why they are right? Now, that's not how science is supposed to be done, right? You're not supposed to want to make the best scientific case for one side and then let others figure out the opposing viewpoint, right? The whole point in some sense is to unearth the truth while you're at it, right? Not let a neutral judge out there unearth the truth, but you are supposed to, as the scientist, engage in this truth finding mission. Right now, when I'm saying economics is sort of this funny thing in between, right? Now, economics as practiced in academia as a science in sort of the best case scenario, yes, has these features, right? There are economists who try to, who struggle with coming up with the truth, right? And they change their opinion based on new information, and they come up with competing theories and then test those theories against the data and so on and so forth. Now, okay, not to get too personal here, but sort of the lesser economist hacks out there in the employ of some, random consultancy with a chip on their shoulder because they never quite made it in academia, right? So, okay, so you can take this very personal, right? And no, I'm not thinking of an individual person here, just to be clear, although I can picture him right there, but no. Right? So there are guns for hire there, right? There are basically people out there who will make your case for you with the best possible evidence that they can muster on your side of the equation, ignoring everything else, right? And then the other side hires this, right? And now, of course, we are, again, not the topic of this podcast episode, but certainly your podcast, right? Over and over again discusses basically, right, the impossibility of getting on with the things we know we need to do, because frankly, there's some hack somewhere, right, who argues the opposite case, even though the truth is not on their side, right? But they justify doing what they're doing because frankly, they are simply saying, hey, I'm doing my side here, someone else should figure out the other side. Okay, now back to the law, right? For solar geoengineering, right? Solar geoengineering research, are there existing treaties? Well, the quote unquote objective legal scholar in the academy, right? And there aren't all that many out there studying solar geoengineering, but frankly, I think the right answer here is to say, look, this is complicated. We don't know. It's up for interpretation. And by the way, no, there is no watertight law written that says, no, thou shalt not. Are there some of these treaties up for interpretation and are being interpreted? And frankly, right, can you find some op-ed written somewhere that says, oh, you are all in violation of a particular treaty? Yeah, you can do that too. Is that the right interpretation? No, I don't think so. Not being a lawyer, I can't claim my own expertise here, but my own reading of the evidence, if you will, suggests that no, we don't have a treaty out there that covers these questions, and therefore it's just very, very difficult to, conclusively decide one way. Why not?
So if I understand it correctly, for solar geoengineering, as you've described it, to work properly, we've got to fly, we're going to apply planes in both the northern and southern hemisphere around the world. So no matter what, countries are going to have to work together on this. Countries across the globe are going to have to work together on this. But, if governments around the world can't commit to work together now to curb global emissions, how do we expect them to work together to do solar geoengineering correctly?
So there's a few things here. So one, there's working together and there's working together. So in this case, I would go back to the free driver properties of it all, which, admittedly is sort of an extreme case here, but no, right? In this case, we don't need 180 countries, 80 plus, so 190, however many there are by now, right, to agree on something. Not that we need this on the mitigation front either, right? There's plenty of sort of earnest papers written about, oh, we all need to agree. Like, no, we don't, right? The US and China and the EU and a bunch of others, right, need to figure out, and frankly, most others then, right, will either won't matter or will simply go with what the big guys want, because frankly, if you want access to 400 million Europeans, to the market, right, sell them stuff, and they are charging you a carbon border adjustment in order to sell there. Yeah, right, that matters to you, and you'll presumably figure out how to decrease your own emissions to pay less carbon border adjustment. Okay, not the topic here, right? But these sorts of things, these sorts of questions of how many countries does it need to agree on something, right, are in fact crucial, because yeah, of course, if it's 190 countries who all need to agree in unison, right, and everyone has veto power, nothing's ever going to happen. And frankly, okay, welcome to the climate talks, right? Now on solar geoengineering, it's just the world looks very, very different. So no, you do not need, right, agreement from everybody to, for example, in this case, fly planes over their airspace. Yes, ideally you have, so yes, one needs to inject sulfate aerosols, both in the northern and the southern hemisphere, something like plus minus 15 degrees. And frankly, in some sense, plenty more work to be done to figure out how this should actually be done and what is, quote unquote, optimal, what is better than something else. What we sort of know is you shouldn't be doing it just in one hemisphere, right? That's pretty clear by now, I would say. So yes, both north and south. Now plus 15, minus 15 degrees actually is a pretty wide range, just to be clear, right? It's not so simple to say, oh, it just happens at the equator and nowhere else. No, it's right north and south. That said, actually, you don't have to do it around the globe at every longitude because, well, prevailing winds, global circulation would in fact spread this stuff almost uniformly around the globe. So Pinatubo, actually, right, the volcano in Philippines in 1991 was sort of a very interesting case because it was very close to the equator. And yes, that gunk, in fact, did spread over the ensuing months all around the globe, right? North, south, and spanning the entire globe as well, east to west, west to east. It's not the case that we have to have, right, universal agreement. Actually, in some sense, it would be interesting, or it would be good. It might actually be better if we needed that sort of agreement from the get-go. The fact that we don't, that it is possible for somebody to start deploying this, more or less unilaterally, not quite unilaterally, because yes, you're flying into other people's airspace and so on. But yeah, there are, right, dozens of countries out there with the capability of deploying solar geoengineering more or less unilaterally. But given how cheap it is, and given how it is not a question of motivating others to join in, but it's a question of quite the opposite, right? Stopping someone from doing it too fast, too much, stupidly. That it has these interesting properties that make it the exact opposite in many ways of cutting CO2 emissions in the first place.
Well, you mentioned moral hazard earlier, and I can't believe we've been talking for 45 minutes and we haven't really dug into the moral hazard problem. So, if geoengineering is this simple fix to runaway global warming, doesn't that disincentivize governments or companies from doing anything about forcing the shift away from fossil fuels?
Okay, so let me start with a very clear statement. Moral hazard is real. It is ever present. Solar geoengineering is not the first and only example of moral hazard. And also for solar geoengineering, moral hazard is very real. So to give you a very specific example, the Newt Gingrich op-ed has already been written. Literally, he wrote that at the height of the Waxman-Markey Obama-era climate policy push food fight. He basically wrote an op-ed in some conservative online rag where he essentially said, we don't need to cut CO2 emissions. We don't need to price CO2. Look at me, I found the solution to climate change. All we need to do is solar geoengineer our way out of this. And that's pathetic, right? Like, that's wrong. It's sad. It's just, running out of adjectives here, right? This is not the right answer. It's just stupid to make that argument. Because no, solar geoengineering is not a replacement to cutting CO2 emissions. That said, is there sort of this moral hazard property out there? Yeah, it is, right? And okay, so moral hazard, right? Just to sort of, for economists, it's sort of obvious that it's about risk compensation and so on. But moral hazard is ever present, right? It's, for healthcare, seatbelts, condoms, like you name it, right? There is, if you don't like the technology, you will argue that a moral hazard exists and it prevents us from doing what we all know is the moral thing to do, it's necessary, and so on. And some of this trade-off is going to be rational, right? And that irks those who don't like the behavior to no end, right? So, basically for healthcare seatbelts, condoms, right? It's sort of usually the conservatives who say, right? Oh, technology bad or intervention bad. It prevents us from taking personal responsibility for our actions, right? On the solar geoengineering front, of course, it's the environmentalists, right? For sort of moral hazard as applied to many environmental problems, to sort of techno fixes on the environmental front. It's often the political left who, frankly, makes a very similar argument, right? Makes the argument that says, no, let's not talk about this new technological intervention because it prevents us from doing what we know we should be doing. And okay, I'm a non-driving 750 square foot city living vegetarian environmentalist here, right? Like, yeah, I think everything is running swimmingly out there in the world? No, of course not, duh. And maybe to add to this, my wife's an abortion doctor, right? So just to give you a sense of where we stand politically on this one, right? On the broader topic here. What about the moral hazard of it all vis-a-vis solar geoengineering? Yeah, it's real. It is. It really is. Should it prevent us from having the conversation about the need to research solar geoengineering? No. And frankly, there's a lot of pointed ways to put this, but I would actually say, and this is actually, this is not my phrase. Usually it's easy to blame editors for, oh my God, they chose a headline for my op-ed and they screwed it up, right? I wouldn't have chosen. In this case, I wrote this column, one of my semi-regular Bloomberg risky climate columns on the moral hazard of solar geoengineering. And the title that I didn't choose, my editor chose, Aaron Rothkopf chose it, all credit to him. Fear of solar geoengineering is anxiety about cutting CO2 emissions. That encapsulates solar geoengineering moral hazard right there, right? So yes, a lot of people are afraid of solar geoengineering, some for good reason, as in they emphasize the risks, the substantive risks. For the most part, that fear of solar geoengineering research, even often, is simply an encapsulation of the worry, the anxiety, the fear of us not cutting CO2 emissions quickly enough. And yeah, sign me up, right? I mean, yes, I'm afraid of that. Like, just look out there, right? In the real world, we haven't been cutting CO2 emissions quickly enough. We should be doing much, much, much more of it. So yes, again, absolutely. That said, actually, so, of course, there's always a that said, but in this case, is solar geoengineering really the reason? Okay, here's the extreme question, right? Is solar geoengineering the reason why we haven't been cutting CO2 emissions? No, of course not, right? No, it turns out, vested interests, they don't need solar geoengineering as an excuse. They have plenty of them already, right? Now, are those same vested interests going to hide behind the possibility of solar geoengineering in order to, pile on yet again, have yet another reason? Like, yeah, again, the Gingrich op-ed has been written, right? So yeah, if the former Speaker of the House points to solar geoengineering as the potential reason, or as the reason why we shouldn't be cutting CO2 emissions, why he is against Obama-era Waxman-Markey climate policy bill, or why he was against it back then, and I'm sure he would still be saying the same thing now too, right? Yeah, moral hazard is real. Should it detract us from worrying about solar geoengineering, especially in light of the not if but when free driver properties of it all? No, I don't think it's a reason not to, especially when you look at how actual people, not the Newt Gingriches of the world, but right, actual people react when you tell them about solar geoengineering, very often the first reaction you get is, whoa, that sounds crazy. That sounds nuts. This is right. Why were you doing it? Well, what that often means is you get the opposite of moral hazard, right? You basically get the response that says, wait, if serious people are worrying about that, maybe there is something to this climate problem after all, and we should be doing more to cut CO2 emissions. And frankly, okay, now me sitting here insisting that that's the response we actually get, of course, wouldn't be right either, right? No, we don't have inverse moral hazard as the response, and therefore let's not worry about moral hazard. No, not true either. But frankly, what that does tell me is what we should be doing is channeling conversations around solar geoengineering in the right direction, which, yeah, does mean we want to get to the point where, we, in some sense, we are describing solar geoengineering the right way in order to invoke that reaction, in order to get the reaction that says, whoa, that's nuts. Let's try to do more to prevent us from ever having to use this technology in the first place. Now we can have a long conversation about whether it's still possible to actually do that, prevent us from having to deploy solar geoengineering in the sort of rational sense of the term. But at the very least, no, the moral hazard conversation should not detract us from the need to research the technology in the first place.
Well, you're a proponent for more research into solar geoengineering, and after reading your book, I definitely am too. So, how should the research be conducted, and who should be the ones doing this research?
Great question. So, I mean, yes, I am a proponent for more research. Who and how, of course, frankly, are the most important questions here, and basically, I can give you now a whole bunch of these sort of, adjectives that, we all think we know are important. And of course, right, it needs to be inclusive. It needs to be global in the sense of, right, it can't just be the global north doing the research, right, and everyone else just, right, reading the papers by, esteemed, elderly white guys, right? Of course not. So it's all of the above, right? That said, I guess some of the most important properties here are this research needs to be all inclusive in the sense it cannot just be scientists, doesn't matter where they sit. Also not just social scientists, right? I mean, in some sense, social scientists are the worst on this one, right? Like we don't just pretend to know about how atoms behave in a vacuum, right? We pretend to know how people behave, right, with their emotions and feelings and so on. And then we come up with grandiose theories about how they behave in certain situations, right, and run with it. So no, it can't just be the scientists at all, right? It has to be a broad conversation among, frankly, all of us partaking in the broader climate policy conversation, right? So, there's sort of the extreme other case, right? Where we basically say, oh, it needs to be all 7.8 billion of us, right? Nah, okay, good luck with that, right? If that's the criterion, right? Then forget it, right? If it's sort of, all 180 plus countries need to come together and come to a watertight agreement to what the research ought to look like, again, good luck with that, right? Might as well say we shouldn't be doing it at all. Right. So no, it's not that. But what we do need to do, what we need to have is broad-based governance conversations, research governance, governance of potential deployment of this technology. There is a distinction here, but frankly, let's just talk, really, right? And this is actually like the one place in the book where you can accuse me of, sort of ignoring lots and lots of research and being a bit flippant is when I talk about governance, because governance to me, and no offense to all the governance scholars out there who study this thing for a living, but frankly, governance to me is simply having the conversation. Now, of course, right, in this case, we are talking about conversation at different levels. So yes, at every level, right? Whether this is the UN Security Council or the UN General Assembly, or frankly, heads of state talking climate policy. No, solar geoengineering research shouldn't, replace any of these other conversations. In some sense, I'm glad that at the Glasgow climate talks, solar geoengineering is not on the agenda. It's not the thing we talk about. That's good, right? We're still, sadly, in a world where we haven't cut emissions nearly enough. So yeah, let's not distract ourselves from, right, to keep the ball in the game here, where we need to focus on cutting CO2 in the first place. But yes, we need to have these conversations. We need to, frankly, figure out in a broad way, not just the US National Academy, not just the UK Royal Society, not just the sort of select few sort of national academies, like the Chinese Academy of Social Sciences has been dabbling in some research here. Germany has a priority research program. These are all important initiatives. The fact that the Swiss are funding this research is great. The fact that the Brits are doing it, the Germans, the Chinese, and so on. But this needs to go much, much further. It can't just be the usual suspects. It can't just be sort of like there's often this name, the geo clique, right? Sort of the same 150 plus people sort of meet over and over again at the same meetings, right? Because they are the ones, right, who are doing the work here. No, that conversation needs to be expanded well beyond. So even though I'm glad, right, solar geoengineering is not on the agenda at all at the climate talks in Glasgow overall, right? And none of these COPs, fortunately. Is it good that there are side events? Is it good that there are side conversations happening? Yeah, it is. And again, not to distract from the main proceedings, but yeah, we should be talking in a much broader way about the research. So I realize I've been dodging your question, right? How and what should we be researching, right? So it's a broad question, broad topic in a very direct sense. We need to be doing more research. We need to be doing much more. Most importantly, we need to broaden the conversation, both among researchers, among policymakers, among basically those who help guide the sort of research, who should help guide this sort of research. It's not yelling at each other on Twitter. It's not yelling at each other on op-ed pages either. It needs to, go beyond that. But yeah, even that is good, right? The fact that we are talking about it more broadly is good, as long as it doesn't detract from the need to cut emissions in the first place.
Well, I think there are a lot of similarities, but in the conversations around nuclear weapons and solar geoengineering, one of the similarities is it's the idea that researching them alone, researching the technologies alone, is a self-fulfilling prophecy of their eventual use. Do you believe this concern is true?
I would say the cat's out of the bag on this one. Even if we wanted to, we cannot squash it's not like there is, we need some additional breakthrough, right? This is not fusion, right? Nuclear fusion. This is not like, okay, we've been 10 years away from doing this forever, right? And therefore, let's just invest, we need more investment in order to have the sort of breakthrough that allows us to then pull the trigger, right? And actually go do it. Solar geoengineering, in many ways, for better or worse, is much further along in the sense that the fundamentals, the fundamental story of volcanoes have been cooling the planet, major volcanic eruptions have been cooling the planet forever, and that there are sort of known ways to do this cheaply, with a lot of impact. Now, that's right. It's not a good thing that knowledge that it is so cheap, right? That's not a good thing. In many ways, it's too cheap, right? Now, of course, in a rational world, there's never any such thing as something being too cheap, right? Because if you don't like it and it's free, just don't do it, right? That would be the rational response. Well, sorry, that's not the world we live in, right? So in that world we actually live in. And, I make sort of a big deal out of this phrase, not if, but when, in the book. Like, unfortunately, or fortunately, depending on your perspective, right? This sort of technology, solar geoengineering, stratospheric aerosols, especially, is not a technology that needs the big technological breakthrough, is not the sort of thing where we need, right, billions of dollars in investment in order to, for example, drive down the cost. No, that stuff is already too damn cheap, right? It's not about the cost. Like, yeah, if you spent a lot of money trying to figure out how to make it even cheaper, sure, right? There might be some marginal improvement that may well make some difference, but no, that's not what we should worry about here. This is not about the costs, right? And I'm saying this as an economist, right? It's usually the sort of people who are accused of only focusing on the cost effectiveness of things. The cost effectiveness of solar geoengineering is not the problem here, is not what we should be worried about. So is there more research necessary? Yes, but right, not into the costs, not into the engineering of making it cheaper. And when you then think through sort of the possible deployment scenarios, right, the possible ways to think about how to, in fact, deploy this technology, frankly, most of these scenarios don't even include, many of these scenarios don't even include the sort of planes, the newly designed high-flying planes that, right, we might want to think about are the most quote-unquote cost-effective ways of doing this, right? Chance is pretty good, I would say, that there's somebody somewhere at some point will want to pull the trigger, try to pull the trigger with some entirely different technology that's frankly much more expensive, relatively speaking, still cheap, still too cheap, if you will.
Well, I think the not if, but when point is the thing for me anyways, where, I just feel like I want to learn more. There's got to be more research. And I hope people that are way smarter than me and way more influential than me do the research too, because that is going to matter a ton. And if you want to have an informed opinion about solar geoengineering, I beg you, please read Gernot's book, Geoengineering, The Gamble. It challenged me. I mean, it definitely educated, informed me. And now I feel like I have a much more nuanced understanding and opinion on why we should be doing more study of solar geoengineering and all of its possible effects. And we'll definitely link to the book in our show notes. Gernot, where else can our audience follow your work online?
Twitter, I guess, if that's a good place. But no, but actually, honestly, on this one, I hate to say it, but it's the sort of conversation that is best had in more words than fewer. And of course, somewhat self-serving of me to say that, having written the book, right? But like, yeah, not a bad place to actually invest the time to say, hey, I'm interested in learning more about this topic. So no, I'm not gonna futz around on Twitter and figure out who is yelling at each other over this topic. Because actually, frankly, unfortunately, when you put geoengineering on Twitter, like 60% of the conversation or so, actually, I even did a research paper on this. So 2/3 of the conversation on Twitter on solar geoengineering is conspiratorial, is about the chemtrails conspiracy, right? So no, actually, as much as I would love to have people follow my own stuff on Twitter, that's not the right place to learn more, right? Unfortunately, or fortunately, in this case for me, I guess, it may well be the old ancient form of the written word between two hardcovers, right? I.e. the book, right? That sort of allows you to actually dig more deeply into this stuff.
I highly recommend it. Gernot Wagner, thank you again for joining the Climate Pod.
Thank you.